Hey there, Math 207 fans. I'm going to make just a final exam topics review for Math 207. I haven't taught it for a number of years. I do want to point out I taught it a couple years ago. I have a lot of resources that I built when I taught it. My lecture materials are pretty sharp for that one. So you can see those. You can see my review sheets, all that stuff. You can see review sheets by section. You can see that I'm fairly robust in making review sheets because I'm trying to help people where they're stuck. I have a pretty extensive review. These are popular things, but not every use them. I'm just making a little video as a matter of kind of a companion piece. But really, you have these first order questions. You learned two ways of solving, and you did some applications. Then you learned this you did a giant case study of second order equations and learned this big application of mass spring systems. And then you finish with Laplace transforms. I haven't taught the course again for a couple years, but in my experience, Laplace transforms are always a major part of the final exam because it's something that hasn't been tested on elsewhere. So what I'm going to do, and in this I've been doing it for all our courses, is do what I think every student should do. I mean, I think it's pretty nice to have an exam archive. Not every school or department does that. We have a really extensive exam archive for most of our courses. Now, I should tell you that my course, I know it says 307, but that has my own exam archive, which has old exams. They're a little bit older with full solutions. So if you want to add a little bit to your studying, you can, but I would start with the department exam archive. Okay, so I'm going to click on the department exam archive. I haven't looked at any of these exams before making this video. And so I want to show you how I would start my studying when I have an exam archive. That's an efficiency. It's great to work exams in detail, and you should. And then I'm going to kind of categorize what I see. I know this is out of focus because I did a screenshot, but I just would like to categorize what we see and ask, would I know how to start? And since it's been a few years since I've taught this, I'm going to be experiencing it a little bit more like a student would. So let's use these three exams as a sampling. I'm just randomly picking three from this year. And we're just going to take a tour. We're doing this sort of studying. We're just trying to get a sense of where our holes are, where we need to study more. And hopefully by the time you got into 207, you're getting a better sense of this. But let's take a look. Okay, what I'm seeing is Laplace transforms. So I'm just making a note. I've never looked at this exam before. We're going to need to, so there's a certain strategy for what you do, and there's a t-squared. Again, that's not something I use every day, but I know this is this Laplace transform stuff. So I've got this, question. I'll just write question one. I won't write 2018 because they're all 2018. But question one, would I know how to do it? And so you sort of go, oh yeah, I have a plan. I have a plan for how to do that. You could spend more time, but when you're doing this sort of studying, you don't want to. But I mean, I have a fact sheet here. We have a clear plan. So we'd have on our note sheet a plan for what to do when you multiply by a t-squared. It's right here. Anyways, then we have a step function. So that's when we were doing this discontinuous forcing piece. So we would need to go, okay, we need a certain way to write that so that we can do our Laplace transform. And then we have another one. And that's kind of what you're doing in the last few sections. You kind of know that's coming. And so you really just want to identify, would I have no idea how to do it, or would I have had a plan? I think that's what students sometimes going into the final. You don't want to have questions where you don't have a plan for what you're going to do. If you really don't have a plan, then go talk to someone, your instructor, your TA, ask them the particular question is, what is my plan when I see these sorts of problems? You should have a step one, step two in your head. Okay, I'm going to rewrite it as a step function. Then I'm going to do the Laplace transform. So, and if you can search around, but the best thing would be just to ask your instructor, but I have several examples here where I go through and do that. Laplace transform practice sheet. Boy, those look pretty similar to what you're doing. Solutions for how to do that. So you don't have to dig too hard if you needed practice. All right, find the inverse Laplace transform. Okay, so that's in this as well. So solving or doing the inverse. So that's question 2. And you should know that basically that's partial fractions. You do partial fractions, do the inverse. Right, the whole point of that Laplace transform is it standardizes a way to solve a lot of problems, but it turns it into a partial fractions problem. Again, I got plenty of stuff on that. Inverse Laplace transform practice sheet. So to me, this is something you could totally prepare for and just blow out of the water. Do well on this. Oh, what do we do if there's an e to the s? Okay. There's some sort of shift. I have examples of that too. I like things where to me, it's a clear plan of how to prepare. Okay, solve that using Laplace transforms. You should have a strategy for that. So this exam is hitting pretty hard on these things, which the instructor might have said, this is what you're doing. Find a formula for the solution of the convolution integral. I think when I taught this course, that wasn't part of what we covered, but it's in right at the end. It's sometimes covered and sometimes not. I think the last time I did it, I had a discussion on it. So maybe that is in my notes. See how well I remember. Write this as a product. So this is coming out of this stuff when you were talking about particular applications of this. I do have a more complete review. I just grabbed a piece of it on my full final review sheet. I talk about the few cases. This is one of the things you talk about. You have to talk about waves quite a bit in that course, and there's a few little skills you pick up. I think I have that over here. Waves, how to deal with waves, how to think about waves. Anyways, but that's stuff you've been doing the homework, so you would need a plan. How do you put those? And that's a certain type of thing. And again, within the topics of Chapter 13, some instructors have a little more emphasis here or there. So it does make the exam kind of a little harder to use. Find the steady state solution. So we're solving this thing. We have a few methods, but that's one of these methods, indeterminate coefficients. What's the steady state solution? What's the amplitude phase? That's using all those formulas back from Chapter 3. Then we have an application here. This looks like one of our Chapter 1 sort of stuff. Then we're approximating. Oh, they give you a table. So that's our first kind of blush with the exam. It appears, a lot of it was heavy on that last piece. I think only one question was from the first part. Okay, let's do another one. We're just trying to get a sense of where our holes are. Laplace transform with a multi-step, and that's a full multi-step problem. So you're going to spend a lot of time initially rewriting that as a step function. So again, if you're still struggling with that piece, I do have some things to help. Another good place to study is just my lecture materials, because you can see me do problems, full problems. That's the review sheet. Oh, that's interesting. I feel like I'm stealing from myself. All right. So then let's keep going. Laplace transform. All right, that's that delta function. So you need to know, this is a Laplace transform problem. You need to take the Laplace transform on both sides, translate it, do your partial fraction magic, do inverse Laplace transform. Here we have a straight inverse Laplace transform. Do your partial fractions, do the inverse. Here we have another inverse partial Laplace transform. So a lot of it is about these skills, and that's why I have this, these couple review sheets. I hand those out in class. So it's kind of an unusual collection of skills in the differential equations course. Other pieces. Solve this. You can use Laplace transform or the method of undetermined coefficients. So you could find the characteristic equation, solve the homogeneous equation, and then guess the form using our method to find a particular solution. I don't know what's better. I'd have to just try and see. State Euler's formula, the one with complex numbers. That's something that must be kind of particular to that instructor's focus. But anyways, consider the differential equation. What would be your form you would guess for your indeterminate coefficients? And I shouldn't use the word guess. I'm a little more careful when I teach this. But this is this method of undetermined coefficients. I have a lot in here about this. Where is that discussion? 3.5. Yeah, I talk through the thought process. So hopefully back when you were doing that, you had a careful thought process. Okay, now we get back to chapter 1. This is studying equilibrium solutions. The equilibrium are 10, -3, and 2. But what can I say about them without actually solving? Because it'd be kind of a pain to solve that. So we did that little analysis of, it's very similar to what you do in Calculus 1. Like what's happening between 10 and negative, so you make a little number line and -3, 2. And if you forgot, that's that piece here. So I'm not solving anything. I'm just kind of doing a recap. Autonomous equations, I think, was 2.5. Yeah. And we do this little analysis, and I have examples. We have an underdamped mass spring system, so that would tell you a few things. What can you say about it? So there is one thing in this particular, in this course, the note sheet is valuable because you have these various named formulas and facts. So you'd want to make sure you have those. If you're worried you don't have the full complement of them, I have it summarized in several places here. I think my exam 2 review might be a good place to go because I really go into detail of each one. Natural frequency, phase angle, quasi-frequency. So there's this kind of collection of facts that are good to remind yourself about. And how we write our answers. There's a lot of dealing with waves and write them in some sort of standardized way so that we can interpret what we have. Okay, so we saw kind of some of the same things. Let's look at one more. Okay, that's a separable differential equation. That's a first order. So that's stuff you were doing back in chapter 2. You even do some of that in Math 125. So then we have a Newton's law of cooling. Again, that's a chapter 2 sort of stuff. So it looks like this test was a bit more comprehensive. And then we have one of these, write down the form of the particular solution. Oh, they have a different name for it. But this is can you write down the form of the particular solution, the undetermined coefficient piece. You have a spring and a damp medium. You know the spring. Okay, so some sort of wave question. The graph is a plot of the displacement. Write down the differential equation governing it. So you're going to, from the picture, you can see a few things like the wavelength is 2. The initial amplitude is 2. There's a few things you can take from it. I do that in one of my reviews. I'd have to think about what the pieces were. Laplace transform. Another Laplace transform, there's that delta function. Graph the solution. Oh, it's some sort of wave you're going to think about. Okay, so that's kind of a mixture of things. I do want to say that if you want to see some more detail in solutions, I would look at some of my old exams. Let's pull one of those up. So sorry, this is not quite as I had planned. And I'm not going to do a full collection of videos. I have too many other courses I'm trying to help with and the one I'm teaching. But you can see through here, I have the characteristic equation I solve. That gives me the solution to the homogeneous equation. And then I guess the form. That's that second piece. We find the undetermined coefficients. We get our answer. Same thing on this one. Here we have one of these mass spring systems with no damping, which tells me a lot. And then we can solve and interpret. Here we have with damping. What's the quasi period? So that you would require you know a bit of the formulas and can interpret. Here we have a mass spring system with an external forcing. So it looks like this. Assume there's no damping and you're trying to get resonance. So I talk about that a little bit. Interpret my solution. So there's this added, besides solving, there is this interpretation piece because you did kind of the big case study in chapter 3. So usually there's some question about that. And then here I have a steady state solution. Here's a particular one we're solving. Here's a setup question. I like that. So this last question, use the reduction of order. I don't think that's covered anymore. So, again, I haven't taught it for a few years, so I can't give you a perfect. The department makes me teach these other classes. Tell them that I should teach this. And then I'd have better, more up-to-date resources for you. But I did just want to say a few things about, since I'm doing this for the other courses, about a good way to start studying. This course, you're going to need a little more help from the homework and from your instructor, but still you can gain quite a bit from the exam archive, and I hope you gained a little bit from that discussion. All right.